Hi students, welcome back again to this course, An Introduction to Mechanical Engineering. I am Professor Yao. Heat as energy in transit. Heating value. The keywords: heat as energy in transit, heating value. In a similar manner, temperature difference, chemical reactions, water vapor, carbon monoxide, and the particulate material. A mass transit bus, the furnace, power plant, or engine. Core. Be mind. Heating value. In the previous section, we saw several different forms of energy that can be stored within a chemical system. In addition to being stored, energy also can be converted from one form to another. For instance, the potential energy of a falling object is transferred to its kinetic energy. In similar manner, the energy that is stored within the fuel by virtue of its chemical structure is released when the fuel is burned. We view the heat as the energy that is in transit or being moved from one location to another because of temperature difference. When they design machinery that consumes or produces energy, mechanical engineers exploit the property of heat to manage temperature and to move energy between locations. When wheel is burned, the chemical reaction that takes place releases thermal energy and waste products, including water vapor, carbon monoxide, and the particulate material. The fuel can be liquid, such as oil for a furnace, a solid, such as coal in an electric power plant, or a gas, such as propane in mass transit bus. In each case, chemical energy is stored within the fuel, and that energy is liberated during combustion. Mechanical engineers design machinery that manage the release of energy stored in the chemical form, and that energy is subsequently converted into more useful form. In a furnace, power plant, gasoline engine, the energy output of the combustion process is measured by a quantity called the heating value, H. The magnitude of heating value describes the ability of fuel that is burned. The greater the amount of fuel that is burned, the more heat is released. The joule is the standard dimension for energy, and in the USCS, the British Thermal Unit, BTU, is the most commonly used dimension for expressing the energy content of a fuel. Historically, 1 BTU was defined as the quantity of heat necessary to raise the temperature of 1 pound of water by 1 degree on the Fahrenheit scale. The conventional dimension for the fuel's heating value are therefore mJ per kilogram in the SI system and the BTU per pound mass in the USCS. In calculation involving the combination of a fuel, the heat Q that is released by burning mass M is given by Q equal mH. The heating values simply tell us the amount of heat that is supplied by a fuel, and it is up to the furnace, power plant, or engine to use that heat as efficiently as possible. The heating value of the fuels can vary widely based on their chemical composition and the manner in which they are burned. The heating value of coal, for instance, can lie between 15 and 35 mJ per kg, depends on the geographical location where it was mined. Specific heat, the key words: specific heat, quenching, to harden the steel, tempering. Likewise, internal energy, specific heat, and asphalt driveway. The Celsius and the Fahrenheit scale, latent heat. During process in mill, hot steel is rapidly cooled by immersing it in a bath of oil or water, quenching. The process of this step, known as quenching, is to harden the steel by modifying its internal structure. Tempering. The material's ductility can be improved by subsequently by reheating operation called tempering. When a steel rod is held at, say, 800 degrees Celsius and then quenched in oil, heat flow from the steel and the oil bath become warmer. The thermal energy that was stored in the steel decreased, and that loss of energy is magnified by a changing in its temperature. Likewise, the temperature of the oil bath and the energy stored within it increase. The ability of material to accept heat and store it as internal energy depends on the amount of material, its physical properties, and the temperature change. Specific heat. The specific heat is defined as the amount of heat that is necessary to change the temperature of a unit mass of material by 1 degree. The flow of heat between the steel and oil is intangible, in the sense that we cannot virtually see it take place. However, we can measure the effect of the heat flow by the temperature changes that occur. When the heat is not the same as the temperature, Changes in temperature indicate that heat has been transferred. For instance, when the sun hits an asphalt driveway during the afternoon, it remains warm well into the night. The large and massive driveway is able to store more energy than a pot of water that was warmed on a stove to the same temperature. A heat flow into an object, its temperature rises from an initial value T sub O to T according to Q equal mc T minus T sub O, where m is the object mass m. Known as the specific heat, the parameter C is the property that captures how materials differ with respect to the amount of heat they must absorb in order to raise their temperature. Therefore, the specific heat has the unit of energy per unit mass per degree of temperature change. The conventional dimension in the SI and the USCS are kJ per kg times degree of Celsius and the BTU per pound mass times degree of Fahrenheit, respectively. Latent heat, the physical property that qualifies the amount of heat that must flow into or out of the material in order to produce a phase change, is called latent heat. Homework: handwriting all keywords and submitting them to Coach Facebook. Just do the online quiz and see you next time.